Hey everybody, this is the notes for section 3.4b, simplifying quadratic solutions, which we did this in class already. I'm just making this video in case you missed it or need to go back over some things. So in this section, we are learning to analyze the discriminant to see the type and number of solutions that an equation has. And we're also beginning to simplify the solutions, okay? So this is just an overview. So remember, the discriminant is the part of the equation underneath the square root, b squared minus 4ac. That is the discriminant. So when you're asked to find the discriminant, they want you to evaluate b squared minus 4 times a times c. Please remember, for b squared, you need to put the b in parentheses with the exponent on the outside. And anytime you are doing the quadratic formula, if it says negative b, that means the opposite sign of b. So the discriminant, remember, when you are finding your a, b, and c, make sure your equation is in standard form, which means it should say equal to 0. When it does, your discriminant is either a number bigger than 0, equal to 0, or less than 0. If your discriminant is bigger than 0, that means you have two real solutions. Two real solutions means that the parabola crosses the x-axis at 2 points. If your discriminant is equal to 0, that means your equation has one real solution. One real solution means the parabola touches the x-intercept at only 1 point. So it's basically a parabola that's sitting on top of the x-axis. If your discriminant is less than 0, that means the parabola does not touch the x-axis at all. Now, this does not mean there's no solution. There are still solutions. Your solutions are imaginary solutions, which we will get into shortly. And then this is a recap of the previous page. So before we said when your discriminant is bigger than 0. Well, if it's bigger than 0, that means it's a positive number. So if it's a positive number, you have two real solutions. So notice this part under the square root, that 31, that is the discriminant. Because it's positive, what happens is when you evaluate the solution, you will do 5 plus square root of 31, you get one answer, and then you do 5 minus square root of 31, and you'll get another answer. And that is why there are two solutions. When the discriminant is less than 0, that means it's a negative number. So if you get a negative number underneath the square root, you will have two imaginary solutions. Again, if I do 5 plus square root of negative 81, I get one answer. And if I do 5 minus square root of negative 81, you get a different answer. So that means two different answers. These answers are imaginary. When your discriminant is equal to 0, you only have one real solution. And that is because the square root of 0 is 0. And if you do 5 plus 0, you're going to get 5. If you do 5 minus 0, you still get 5. So anytime you have 0 under the square root, you're only going to get one answer because you are going to be adding and subtracting 0, which means you get the same answer. So let's talk about the square root of negative 81. Why is the square root of negative 81 an imaginary number? Well, if you try to put the square root of negative 81 in your calculator will say error or undefined. And that is because you cannot have a negative under the square root. Well, why not? What does the square root mean? For example, the square root of 16 is 4. The reason why it's 4 is because we know that 4 times 4 equals 16. Or that's the same as saying 4 squared equals 16. Okay, so a square root is basically something times itself that gives you that number. Okay, so please don't get it twisted. Square root does not mean divide by 2 or split it in half. It means what number times itself give you that, or what number squared. So square root is like undoing a square. So here you have 4 squared, which equals 16. The square root is the opposite of to the second power. There is no number times itself that will ever give you a negative. That is why you cannot have a negative under the square root. I'll have to answer that a little later. Let me pause right quick. Okay, I sent a quick message. Alrighty, so let's practice these. So we look at each equation, we're going to find the discriminant and then use the discriminant to tell what type of solutions it has. Remember, if your discriminant is a positive number, you'll tell me 2 real solutions. If it's a negative number, you'll tell me 2 imaginary solutions. If we get 0 for the discriminant, there is 1 real solution. So for number 1, first of all, we check to see if the equation is in standard form. It does say equals 0, so yes, it is in standard form. That means we could look at the equation and see that A is 1, B is 12, and C is 36. When we do find the discriminant, we are using B squared minus 4 times A times C. So if you do 12 squared minus 4 times 1 times 36, we get 0 for our answer. So the discriminant is 0. Since we got 0 for our answer, this means our equation has 1 real solution. For number 2, again, this equation is in standard form because it says equals 0. So just by looking at it, we see that A is, darn it. Thought I had it on here where I can make it appear. But A is 1, B is negative 1, and C is 6. Okay, so A is 1, B is negative 1, and C is 6. So B squared minus 4AC. Notice, again, when I do B squared, I put the B in parentheses with the square on the outside. So negative 1 parentheses squared minus 4 times A times C. We got negative 23. Our discriminant is a negative. That means it is 2 solutions, but they're not real. They are imaginary. For number 3, this equation is not in standard form. Okay, so to put the equation in standard form, you will have to subtract 24 on both sides. When you do that, you will get 4n squared minus 4n minus 24 equals 0. It's important that your equation is in standard form. If it's not, you're going to have the wrong numbers for your A, your B, and your C. And if your A, B, and C is wrong, then when you find the discriminant, it's going to be wrong. So you should be using A is positive 4, B is negative 4, and C is negative 24. And when I found the discriminant, I did B squared minus 4 times A times C. I got 400. 400 is positive. Remember, when you have positive solution, when your discriminant is positive, then you have 2 solutions and they're real. And for number 4, so I didn't do that one with you. But again, this equation is not in standard form, which means instead of that minus 4, instead of saying equal negative 4x, you wanted to say equal to 0. You have to do a plus 4x squared on each side. When you do that, you will get positive 4x squared minus 5x plus 10 equals 0. When you write your equation in standard form, make sure it is in order. The square term should be first, followed by the x, followed by the c, the number with no x. A is always with the x squared, B is always with the x, and C is the number without an x. So your A is 4, B is -5, and C is 10, and I will not compute that one for you. I'll let you do that one on your own. Okay, so imaginary numbers. So we said earlier that you cannot have a negative number under the square root, right? Because there is no number times itself that will ever give you a negative, which is why mathematicians created an expanded system of numbers using imaginary unit I. I represents the square root of -1. So if you look here, it says if R is some real number, then the square root of -r is I square root of R. In other words, if you had the square root of a negative number, to turn the negative into positive, you're going to take an I out. When you take an I out, you're basically taking out -1, and it turns your number positive. So like the square root of -3 is I square root of 3. Okay, anytime your square root is a negative, you will turn a negative into a positive by taking I out. Then whatever your square root number is, if it's possible to simplify it, you will simplify it. So rule of thumb, never ever leave a negative under the square root. Always take an I out so that you can turn it into a positive. So the directions say simplify the square root. If the square root is a negative, you must take the I out. Then you can try to simplify the number if possible. So for number 1, see that's a negative under the square root. So the square root of -5, let me use my little highlighter here. You want to take that negative out by putting an I. So you're going to get I and then square root 5, like that. Now, the square root of 5 cannot be simplified because there is no number that goes into 5 except for 5 and 1. So that's your answer, okay? Number 2, the square root of 16. So there is no negative, so we do not need an I for number 2. But the square root of 16, remember, that equals 4 because 4 times 4 gives you 16. Okay, square root of 16, that's the same thing as saying square root of 4 squared. Remember, the opposite of squared is square root. Oopsie. Let me just erase that. Number 3, the square root of -25. See that negative right there? Got to take the negative out by putting an I. So now our 25 turned positive. But we know the square root of 25 is 5. Okay? The I is still there. So our answer to number 3 is 5I. So rule of thumb, if you take an I out of a square root, put it in the front. But if your square root gets simplified to a regular number, then put the I behind the number. Number 4, square root of -36. Again, we have a negative right there under the square root. That means we have to take out an I, and we're left with square root of 36. But square root of 36 can be simplified, which is just 6, and I is still there. So number 4, the answer is 6I. Number 7, square root of 49, there's no negative, so we do not need an I. 7 times 7 is 49, so square root of 49 is 7. Number 6, square root of -100. See the negative? Gotta take an I out. So we have I times square root of 100. Square root of 100 is 10, because 10 times 10 gives you 100. And remember, the I is still there. Now, number 7 is different. Put a star by that one. The square root of 18. So there is no number times itself that gives you 18. Let's think about our perfect square numbers for a minute. We know that 1 squared is 1. 2 squared is 4. 3 squared is 9. 4 squared is 16. 5 squared is 25, etc., etc. Now, when you're trying to simplify a square root, if there is no number times itself that gives you that number, like there is no number times itself that equals 18, you want to see what is the highest perfect square number that can go into 18. These numbers right here are perfect. Like these numbers, why is my highlighter not working? Uh-oh, I think my computer froze. But those numbers 1, 4, 9, 16, and 25 are all perfect square numbers. So out of my perfect square numbers, I know 25 cannot go into 18. 16 does not go into 18, but 9 does go into 18 because 9 times 2 equals 18, right? So since 9 times 2 equals 18, I know the square root of 18 is the same as the square root of 9 times the square root of 2. The square root of 9 is 3, and the square root of 2 cannot be simplified. So my final answer for number 7 would be 3 times square root 2. And for some reason, my computer is freezing up or something. I'm hoping this video is still recording. I'm about to find out in a minute. Message me if you have questions.